All right, so let's take a look at how we would figure out the beam width, if you would, of this particular antenna. Now remember that this circle is representing 360 degrees. So you don't have to do like real measurements. You just see where it's at plotted on the circle, and then see how many degrees are between. All right. So having said that, you're going to see that the solid circles represent the change in dBs, the -10, -20, -30, and the 30 dB line. Well, let me take a look here with how they're setting this chart up. All right, so what we want to do is figure out where is the strongest point of this particular setup. And the dotted lines that you see here are actually going to be representing the angle of the beam width, or what the beam width actually is. So you would measure, going to, let's say, point 1, the strongest part of that signal. So that's where we would start with. And then what we do is that we're going to move along that pattern from the peak signal, step 2. We're going to move in both directions till we get to a point that we have a -3 dB loss, right? That we're at half the power. And when we get to those points, and I'll put a little extra line there, when we get to those points, then what we have, or at least now know, is what the actual angle of the beam width is between those 2 points. So when we get to half power, right, we go back to the center of where that axis or that antenna is, and then we can determine from there what the actual angle is of that beam width.